Okay, day 2 of not being together. I asked you to do, from the last day, number 5 and 6 on the front side of this sheet, harder problems with acceleration. So let's take a look at them. Number 5 says a rock is dropped from a bridge which is 30 meters above the water's surface, and it slows down instantly upon hitting the water to a quarter of its speed, sinks to the bottom at constant speed. It takes 4 seconds from the time it was dropped until it hits the bottom. What is the depth of the water? Okay, so here's the bridge, here's the water, and then here's the bottom. Okay, and so the two parts are really, well, it falls through the air, and then as it hits the water. So it says a rock is dropped, which means VI is 0. And of course it's falling through the air, so A is 9.81 meters per second squared down. And it says it's 30 meters above, so delta D is 30 meters above the water, also down. And it says it slows down instantly upon hitting the water to a quarter of its speed, and then it falls at that speed, at a constant speed. So the V in the water is VAV. And it's a quarter. It says a quarter of its speed. What speed? That speed would be the VF above. So the VAV in the water is a quarter of the speed above. And it says it takes 4 seconds for the whole thing to happen. So we don't know what its time in the air is. But if we did, then its time in the water would have to be 4 seconds minus that. Okay, if we call this air. Okay, and the question wants to know what's the depth of the water. So we're looking for delta T of the water, which we can't find until we find the two things up here. So if we look at our givens, we have an A, a delta V, a VF, and a delta D. We should be able to, a VI and a delta D. We should be able to find delta T and VF. Doesn't matter which one you find first. If we use delta D is equal to VI delta T, 1/2 A delta T squared, we can get our time because this will go to 0. So T squared will be equal to, multiply both sides by 2 and divide by A. So 2 times 30 divided by 9.81 meters per second squared. And we don't really have to call down negative because everything's going down. So 60 divided by 9.81, and then take the square root, and when you do, you should get 2.4731 seconds. This is the time in the air. To get the time in the water, take that away from 4 seconds, and the time in the water should be 1.5269 seconds to be used shortly. Before we use it, though, we need to find our VF in the air. So in the air, we have a VI, an A, and a delta D. Probably safest to use VF squared is equal to VI squared plus 2A delta D, just in case you screwed up the time. Yes, you could use A equals VF minus VI over delta T, but just in case you screwed up the time, let's go here. The VI goes to 0, so VF squared is equal to 2 times 9.81 meters per second squared times 30 meters. Don't forget to take the square root when you do that, and you should get a VF of 24.261 meters per second. Okay, so both of these are for the air. So now for the water, the VAV is a quarter of that. So since you have that in your calculator, divide it by 4 or multiply by 0.25, and you should get 6.065 meters per second. And so now we know VAV is equal to delta D over delta T, So delta D is equal to VF delta T. So delta D is equal to, that's 6.065 meters per second times 1.5269 seconds. And you should get a delta D of 9.261 meters. Okay, number 5 is done. Number 6. Number 6 is the skydiver. Okay, so I'm gonna go like this because he's skydiving. He leaves the plane at an altitude of 3,000 meters, falls freely for 6 seconds before opening her chute. Because of air resistance, experiences acceleration of only 8 meters per second squared during free fall, fills with air. Okay, so, and then constant speed. So it sounds like there's 3 seconds before chute, while the chute is filling, and then after. So the constant speed part. Okay, so it says he steps out, so VI is 0. When he's free falling, it says the A is in 9.81, it's only 8 because of air resistance. Because of air resistance, the diver experiences an acceleration of only 8 meters per second during free fall, which is before the chute. As the parachute fills with air, the diver slows to 5 meters per second. So slows to the VF is 5 meters per second. And this happens in 10 seconds. Oh, and up here it says he falls 6 seconds before pulling the cord. If the diver continues falling at this speed, which will be his VF, and at this speed should be the VF, 5 meters per second. For the rest of the dive, how long will it take him to reach the ground? So down here we don't know delta T3, we don't know delta D3. Here, the VI of the section while the chute is filling should be the VF that they reached in the first part. Okay, we also don't know the delta D1, and we don't know the delta D2. Okay, and we need to know those so we can get the delta D3, because we know the full thing here is 3,000 meters. So I would suggest starting with the first part. And from the first part, we can find our VF and our delta D. So using A equals VF minus VI over delta T, the VI is 0, VF equals A delta T. So 8 meters per second times 6 seconds, the VF is 48 meters per second. And so that becomes the VI in the second part, which was why we needed it. Now the delta D1 would be VI delta T, 1/2 A delta T squared. This will go to 0. Delta D1 then 1/2 of 8 meters per second squared times 6 seconds squared. Delta D1 36 times 4, 144 meters. This one we will use eventually to get our delta D3. So now we go to part 2. Here we can find our A now. A is equal to VF minus VI over delta T. So A is equal to 5 meters per second minus 48 meters per second divided by 10 seconds. So A is equal to 43 over 10, which should be 4.3 meters per second squared. Okay? And the negative, oops, sorry, lost the negative, would mean it's going up. That's the point of the